I just want to emphasize a couple of things here. Number one, right here, we know based on the degree of the equation that it's going to be either a parabola or look like the cubic graph, okay? So we can probably, right up here, squeeze in two cases. If degree is even. One, the picture is going to look roughly something like this, where it looks like a parabola, but then what I'm going to do, I think I have a marker, is say that there's going to be some stuff going on here in the middle that we don't know about yet. But in the end, it's going to come back up. This is called a global picture, okay? So you know that if it's a parabola, when does it open up usually? How do we know if the parabola opens up? What do we look at? The number, yeah, the lead, we call it the lead coefficient, okay? Which we're going to call A. This only happens if A is positive. Okay? Does that make sense? If the leading number is a positive, the parabola-ish shape is going to open up. If it's negative, what's the other case? Then it's going to look something like this. Parabola upside down with some stuff going on in the middle. And then it's going to come back down. This is when the lead number is negative. What I mean by stuff, guys, is that it could come back up and down and, you know, do a bunch of little things in here, but if you step away and look at the graph from far away, it looks kind of like a parabola. Okay? So that's if it's even. Are there any questions on that?
What's that little sign?
What sign?
Under the line. The circle. Is that 2? Is that 2?
Here?
Yeah.
That's a number 2, yeah. Two cases, number 1, number 2. Now, if it's odd, so two cases, if it's odd, same idea. If the leading number, if the lead coefficient's positive, then it's going to look like what? Like that, right? So, looks like this, but then you got stuff going on in the middle that we're going to figure out in a few minutes, but eventually it's going to have to come back up. So this is your cubic shape, but you know, here it might bounce around a little bit. And the second case, which I'm running out of space here, but if it's less than 0, if the degree is odd, then where does it start? It starts upper left, and then there's going to be some stuff going on in the middle that we'll figure out with some work, but then eventually it's going to have to come back down. So do you guys kind of see the global picture here? Still kind of looks like a parabola, or still kind of looks like a cubic graph. There's just going to be some details in the middle based on what the intercepts are and such. Okay? All right. Now, I'm going to do a couple of examples here, which should kind of make life hopefully easy, because honestly, I don't think graphing polynomial functions are that bad. So I'll do a few of these. Let's start with the first one, right here. We could multiply everything out, but I'm going to say let's not do that, because we like factored stuff, right? Can we tell, though, what the degree is going to be?
Cube.
It's going to be x cubed, so we say that the degree is odd here. Is the leading term going to be positive or negative? If you FOIL everything out, you guys see it's just going to be a regular x cubed at the front. So I know that my graph's going to start down here somewhere, do some stuff in here, and then it's going to end by going up over here on the right side of the graph. What we're going to do right now is figure out what's going on in the middle. So let's start with X-intercepts. To find X-intercepts, you set what equal to 0? So basically we say, let's make this all equal 0, and then we get how many different X-intercepts? What are they? 1,
-3, -5.
Very good. So go to your x-axis. You don't have to do like tick marks, okay? Don't do tick marks because we're going to have x-intercepts that are like 10 or 20 or y-intercepts that are -100. You're not going to sit there and do little tick marks, okay? You're just going to label it. 1.
So like a guesstimate or
Yeah, 3.
Wait,
It's negative.
it's negative.
Oh, shoot. Thanks, guys.
Yeah.
So we have -5, -3, and 1. All right, how do I find a y-intercept?
It's negative.
Doesn't answer my question. Plug in 0 for x. Good. Set x equal to 0. So then if I plug 0 in here, 0 minus 1, I'm going to show this step only once. 0 plus 3, and Saeed was right.
It's a first.
If we're going to say comments like that, then I'm going to say comments like, if you're always right, then last quiz wouldn't have happened, right?
Oh.
So let's not be cocky, okay?
Don't cross Mr. Jan.
So we get -15. Everybody see why we get -15? Yeah, this is just -1, +3, +5, multiply them all out. -15. I guess the better thing would be Saeed would be always right if he did a little bit more homework, probably. That's true.
That's the YouTube friendly version.
Yeah.
Or any of it.
Oh wait, this is going
Okay.
on YouTube.
All right, here we go. So,
Wait, are we recording?
yeah.
Yeah.
Hello, internet.
Y-intercept is -15. Here it is. All right. We said we started down here. We're going to do some stuff here, and then it's going to come back and end this way, right? So what I'm going to do is start by drawing this. This is the bottom of the graph. It's going to go through -5. But what's it going to have to do? It's going to have to come back down and hit -3. So I don't care how high you go, or if you only go a little bit, but something like this would be good. Once it goes through the x-intercept, what does it have to hit next?
-15.
So then it's going to have to do something like that. And then
It's so fun.
it's going to have to go back through and hit 1. And then there's your graph.
Looks like a party.
That is top right.
Over here.
That's still tough.
That's still top right.
And when you take
Yeah. In fact, look, when you guys draw these, the final parts of the graph should be very steep. Okay? For example, here's what I don't want to see. Let me see if I can. Here's what I don't want to see. So if you have your intercepts that look like this, this is a bad graph. Because what happens as x gets really big?
It starts to.
It gets really steep, right? Y is really big. So when you draw, you see the difference between this graph and this one? Your final parts of the graph should be really steep. Okay? Your curving should be smooth. We shouldn't have any like jagged edges, right? Okay? Any questions on this first example? Okay. Let me do number 4. You guys understand that if it's negative, it just starts opposite, right? Like starts up here and does that? Okay. Let's just do 4 because this one's interesting. What are the x-intercepts? 0, 2, -3. Okay. So now before we... Oh, y-intercept. Let's find that. If you plug 0 in for x, 0 times anything
So it's 0.
is going to be 0. Right? Because it's 0 cubed and then times a bunch of other stuff. It's just going to be 0. I don't care what the other stuff is. All right. The difference between number 4 and number 1 is that all of these intercepts, x minus 1 was to the first power, x plus 3 was to the first power, and so was x plus 5. Here, this x is to the third. So here's what this is going to mean. When you graph 0 for the x-intercept, right here it should look kind of like a cubic. Okay? When you graph 2, it should look kind of like a straight line, or straight, okay? When you graph negative 3, it's going to look like a parabola at that x-intercept. So here's what it looks like. Let's put the intercepts, so we have 0, 2, and then negative 3. And we said, oh, we didn't do that yet. What's the degree, odd or even? 3, 4, 2 makes 6. So this is an even degree graph. Is the lead coefficient greater or less than 0?
Greater.
So that means that it's going to look like a parabola, something like this, right?
Yeah.
Okay, so I'm going to start up here because we want to make it steep as it gets close to negative 3, right? And I'm just going to check, where did this negative 3 come from? It came from this factor, but it was squared. So what it's going to do is bounce off of the x-axis and look like a parabola right there. Anytime it's quadratic for the intercept, that's exactly what it's going to do. It's just going to bounce right off of that x-axis.
Can you just leave it?
Yep, well, we're going to continue it, right? Eventually, what does this have to do?
Arc back down.
It's got to come back down because the next point on the graph is 0. But now where did 0 come from? It came from this x cubed, so it's going to have to look cubic. So you're going to do your best job to make it look like a squiggly cubic graph.
What? It's confusing.
Okay?
But then you have to curve
But then it's got to come back, and now at 2 was to the first power, so that means it's just going to come back and go straight through like a line. And it should, what did we say? It was going to end like a parabola, right? So there it is, with some stuff going on in the middle. Yes, it kind of does. Are there any questions on what, like where we got these shapes from?
Wait, what does it look like?
Urena.
Did you multiply 3 times 2?
No, you always add up the x's. Like if you're multiplying, when you do x cubed times x, that becomes x to the 4, right? But then you got an x squared in here. So x to the 4 times x squared becomes x to the 6.
And the exponent.
Does that make sense? So it's not 3 times 1 times 2, which actually in this case still ends up being 6, but that's a coincidence. Okay?
It's not real.
Yeah. Are we good with this? Okay. If you look at 5, 6, 7, 8, the only thing that's different, so I'm not going to bother doing them. You guys will. What do you have to do here first? You have to factor it. Okay, you have to factor it. Same with this one.
It's supposed to be.
Yeah, it's supposed to be 8. No, I'm not going to do 4. There's that mentality again. Oh, there's a hard question. Let's ask Mr. G to... There's a hard question. I'm going to try to figure this out. Okay? All right. We're going to talk briefly about division. Just go to page 6.
Hey, Mr. G, you numbered these. Can't do it.
Because we're short on time, I'm just going to review with you how to long divide. If you don't know how to long divide, then just pay attention. It's really easy. Okay? Here's how it works. Does 4 go into 1? No. Does 4 go into 12? Yes. How many times?
3.
So then what you do is put a little 3 above the 12. 4 times 3 is? You subtract. So what we're doing here is you multiply this number with the divisor. You get 12. You subtract. What do you get? 0. You bring down the next number. And now you repeat the process. Does 4 go into 6?
Yeah.
How many times?
1.5.
It's just once.
And 5.
1 times 4 is? Subtract 2. We're done because there's no more numbers to bring down.
So we do
So this is 31 with a remainder of 2. Which translates to 31 plus the remainder over the over the divisor.
31.5.
Guys, just let me do my thing here, okay? There's a reason why we're writing it like this. Just go with it, okay? I know it's 31.5. Everybody knows it's 31.5. But YouTube knows it's 31.5, okay? Does everybody understand where I'm getting this answer from?
Yes.
Okay, now, when you're doing long division, the process is very similar, but all you pay attention to is like this x out in front, or whatever the first term is. Okay? So I'm going to phrase things very much the same way. Does x go into x squared?
Yes.
What time x times what gives you x squared? So now what I'm going to do is line up. See how there's an x in the middle? I'm going to put that x, which is like the 3 I put over here, right above it so it lines up in the right column. Okay? And then we did 3 times 4 to get this number here, right? So we're going to do x times all of this, which is x squared plus x, and then we subtracted, right?
Yep.
So we're going to subtract this, but I'm going to put parentheses around this because we don't want to get confused when we're doing it. Okay? X squared minus x squared is 0. 3x minus x is 2x. That's like the 6 or the 0 that we got here. What did we do after that? We bring down the next number, and here the next number is a negative 4. Okay? Now we repeat. Here I did 4 goes into 6 one time. Now I'm going to say again, x goes into 2x.
Twice.
Everybody see that it's twice? Because x times 2 is 2x. So I'm going to put plus 2. Everybody good with that?
Okay.
And then we always subtract whatever we get when we take this number times the divisor. So 2 times x plus 1 is 2x plus 2. And then we just subtract. 2x minus 2x is 0. But what's negative 4 minus 2? Negative 6. Now we're done because there's no numbers to bring down. So the answer here, the quotient would be, well, we'll say this. The answer is x plus 2. The remainder was negative 6, okay? But we can write that as plus remainder over divisor. Just like we did 2 over 4 here, which was 1/2. It's the same thing, it's just you have some letters in there now. Question?
Okay, just make it x plus 2 minus.
Absolutely. The question was, can you just write this as x plus 2 minus 6 over x plus 1? Yes, absolutely. Are there any questions on how we got that?
Wait, so you can write it as a polynomial over that divisor?
You mean here?
Yes. So
Potentially.
So you could write x minus 4 all over x plus 1.
But this degree would have to be bigger. It's always going to be, like for example, you wouldn't have a polynomial up here unless this was like a quadratic, in which case this might be linear then. You see what I mean? Like if this has a degree 1, this should have 0 x's. If this down here, if we're dividing by a quadratic, then our remainder could be a number or it could be like 2x plus 1 or something like that.
So just leave it as is?
Yes. Yep. We good with that? Okay. The only advice I'm going to have you guys, like let's look at number 2 real quick. Let's set it up. I'll let you guys finish it later.
Okay.
2x plus 1 is the divisor. The first term is 6x cubed. But what should come next? X squared. We don't have any of them, right? So very important. I call it a placeholder. Go ahead and write in plus 0x squared because it helps you organize everything and keep things the same, like we did earlier in the example above. And then yes, now we do minus 2x plus 3. Always use placeholders if you're missing, bless you, if you're missing a number like an x or if you're missing an x squared. Use placeholders. It'll help you make things very easy. Does that make sense? Okay. Last, the shortcut. So if you turn the page to page 7.
Oh,
Okay. By the way, most of this should be review except for the graphing polynomials part. You did long division in Algebra 2. You did synthetic division in Algebra 2. You just might have forgotten. So we're going to review. Okay? I'm going to do the example right here. Okay? The first thing you do, well, first of all, let me clarify. Synthetic division only works if this number down here, if this term is linear. You cannot do this if it's like x squared plus 4 or x squared plus 2x plus 1. Not only does it have to be linear, but this x has to have a coefficient of 1. Okay? So synthetic division only works if you see like x plus or x minus on the bottom. And that's the only time you should do it. Okay? Now here's how it works. What you do first, you take the denominator, you set it equal to 0. What do you get?
X minus 3 equals 0.
So x is
3.
3. You take this, we call it a root. Okay? You take this root, you put it in this little half box.
You take all of them.
Okay? And then now what you do is you write over here, you write the coefficients of what's on top. So we start with how many x cubes? How many x squareds? How many x's? And then the constant? -4. We use placeholders here too. Never write just the numbers you see unless you have everything covered. Does that make sense? Okay? So once you set it up, you always start by bringing down this first number. So 1 is what we write here. And then now you just take this number times the number in the box. 1 times 3 is 3. And then now you always add. 2 plus 3 is 5. Now you repeat. What's 5 times 3? 0 plus 15? 15. And now you repeat. 15 times 3 is 45. And now you add. -4 plus 45 is 41. So now this represents, think about what's going on here. We have a cubic divided by an x, right? So this should be a quadratic and then a remainder. So this 1 represents 1x squared. This 5 represents 5x. The 15 represents your constant. And then this right here, that's the remainder. So how do I write that? Plus 41 over, what was the original divisor?
X minus 3.
There you go. Does it make sense? Does it make sense? Okay. Yes.